This podcast is brought to you by Empor.top, the stories of top companies. Disclaimer. This AI-generated content is for informational purposes only and should not be considered as investment advice. Ouster, the quest to give machines eyes. In the spring of 2023, something remarkable happened in Silicon Valley's lidar industry. The prodigal son came home. Ouster, a startup founded in 2015 by two engineers who had quit their jobs at a rival lidar company in frustration, completed its acquisition of Velodyne, the very company that had invented real-time 3D lidar for autonomous vehicles. It was as if the rebellious young engineer had returned not just to match the master, but to absorb him entirely. In 2024, Ouster grew its revenue substantially from the previous year. The company now stands as one of the last pure-play lidar companies trading on American exchanges, a survivor in an industry that has witnessed spectacular consolidation, bankruptcies, and the rise of formidable Chinese competitors. But how did we get here? How did a technology born from a desert robot race become the contentious center of autonomous vehicle development, geopolitical tension, and one of the most dramatic SPAC boom and bust cycles in recent memory? This is a story about sensors. Those tiny devices that give machines the ability to perceive the world in 3 dimensions. It is a story about the perennial battle between analog and digital approaches to technology, about Moore's law finding new territories to conquer, and about what happens when an industry's fundamental technology assumptions get overturned. It is also a story about Angus Pacala, a Stanford-trained engineer who believed that everyone else in the lidar industry was building sensors the wrong way, and bet his company on proving it. The themes here are universal to technology investing. The DARPA origins that spawned an entire industry, the Moore's law moment that could transform lidar economics, the SPAC bubble that provided both capital and cautionary tales, and the inevitable consolidation that follows technological maturation. Along the way, we encounter patent wars, boardroom drama, Chinese competition, and the fundamental question that haunts every autonomous vehicle developer. Can machines ever truly see?
The DARPA Grand Challenge and a Subwoofer Inventor's Epiphany. To understand Ouster, you must first understand the man whose technology it would eventually acquire, and in many ways, supersede. David Hall founded Velodyne in 1983 as an audio company specializing in subwoofer technology. For over 2 decades, Hall built a successful business, creating high-fidelity speakers for audiophiles. But by the mid-1990s, Hall expanded his interest to other technical areas, exploring semiconductor technology, robotics, and related fields. He also took part in robot wars competitions, gaining practical insights into sensor technology and machine automation. A defining moment came in 2004 when Hall joined the inaugural DARPA Grand Challenge with an autonomous truck. The Defense Advanced Research Projects Agency had announced a competition for fully autonomous ground vehicles to navigate 150 miles through the Mojave Desert. The prize, $1 million, later doubled to $2 million for the 2005 race. The implicit stakes were far higher. DARPA wanted to accelerate the development of autonomous military vehicles. Initially relying on stereo cameras, Hall soon focused on lidar after discussing navigation methods with other competitors. The cameras simply could not provide the reliable depth information needed for autonomous navigation. It became clear that stereo vision was not sufficient to see all the objects all of the time. We needed a sensor that could see 360, worked day and night, and operate in real time, Hall noted. What happened next would transform Hall from an audio entrepreneur into the pioneer of autonomous vehicle perception. The 2005 Grand Challenge piqued the interest of Hall, who had the idea to enter in February 2005. By September, he'd installed his first prototype, which eventually became Velodyne LiDAR's breakout sensor, the HDL64E. The inspiration came from an unexpected source. The whole idea of this is I used to race bicycles, Hall explained, and they had a camera that would film the finish line. The film would go across a slot and form a linear picture of the bicyclists running through, so I thought, that's a great idea. I got to use that for something. That something became Hall's mechanical-electrical hybrid design, where 6432 or 16 lasers obtain distance data linearly while being mechanically swept across the landscape to generate a 360 degrees real-time image. Hall filed a patent in 2007 for a lidar design featuring 64 lasers in a rotating housing, spinning at up to 900 revolutions per minute. This approach allowed autonomous systems to map and detect their surroundings in real time, without depending solely on GPS. Although the sensor initially cost around $80,000, it attracted considerable attention from every team working on autonomous vehicles. Velodyne developed new multi-laser sensors for the 2007 race. The Hall brothers sold their lidar system as a steering input to 5 of the 6 teams that finished the 2007 challenge. The HDL-64E was used as the obstacle detection sensor by 5 out of the 6 finishing teams at the 2007 DARPA Urban Challenge, including the winner, Carnegie Mellon University's boss. From government race to commercial gold rush. What started as a government-sponsored research competition became the foundation for a commercial gold rush. As interest in autonomous vehicles surged through the 2010s, Velodyne's lidar devices became the de facto standard. Google's Waymo, Uber, Apple. Every company with autonomous vehicle ambitions needed Velodyne sensors mounted atop their test vehicles. Those distinctive spinning cylinders became visual shorthand for autonomous vehicle in countless news stories and investor presentations. Velodyne lidar was spun off from Velodyne Acoustics in 2016. The timing was perfect, or seemed to be. Autonomous vehicles were the hottest topic in technology, and Velodyne had the perception technology that made them possible. But Velodyne's success contained the seeds of its future challenges. The company had built its empire on analog lidar technology, a complex mechanical system with hundreds of discrete components. Each channel required its own emitter, laser driver, receiver, and analog-to-digital converter. Increasing resolution from 16 to 32 to 64 channels meant scaling complexity linearly. The sensors were expensive to manufacture, difficult to make reliable at scale, and fundamentally limited by their mechanical nature. The lidar gold rush had begun, but not everyone believed Velodyne had found the right vein to mine. Among the skeptics was a young engineer named Angus Pacala, who was working at a Velodyne competitor called Quanergy, and who was becoming increasingly convinced that the entire industry was building lidar the wrong way.
The Stanford engineer's revelation. Angus Pacala's educational background is rooted in mechanical engineering, with both his undergraduate and graduate studies completed at Stanford University. He earned a Bachelor of Science, BS, in mechanical engineering, which laid the foundation for his technical expertise. Building on this, Pacala pursued a Master of Science, MS, in mechanical engineering with a focus on mechatronics. Before founding Ouster, Angus Pacala was Director of Engineering at Quanergy Inc. from November 2012 to February 2015. Quanergy was one of the early lidar startups trying to build solid-state sensors that could eliminate the spinning mechanisms of Velodyne's design. But something was bothering Pacala. He saw an industry locked into technological approaches that couldn't possibly scale. Analog lidar required complex assemblies of discrete components. Solid-state approaches promised simplification, but couldn't achieve the performance needed for autonomous vehicles. The entire industry seemed stuck in a local maximum, optimizing technologies that were fundamentally limited. The insight that would define Ouster came from an unexpected source: consumer electronics. By 2015, vertical cavity surface emitting lasers, VCSELs, and single-photon avalanche diodes, SPADs, had become ubiquitous in smartphones and other consumer devices. Apple's Face ID used them. Countless smartphones employed them for depth sensing. These components were cheap, mass-produced, and getting better every year thanks to billions of dollars in consumer electronics investment. What we saw back in 2015 was an opportunity to design a lidar sensor that could ride a wave of innovation in VCSEL and SPAD technology, combined with one of our key breakthroughs, new micro-optics that use light more efficiently to build a high-resolution digital lidar that could meet customers' required specifications. The result of our work is a low-cost, integrated digital lidar sensor. Because VSCLs and SPADs have improved in the intervening years, we have sensors today that are affordable, highly reliable, have the highest resolution available, are capable of 200-plus meter range, and have many years of improvement ahead. This was Pacala's bet. Build lidar like a chip company, not a mechanical systems company. Consolidate all the complexity onto silicon. Ride Moore's law instead of fighting against it. Building the digital lidar architecture. Angus Pacala co-founded Ouster in July 2015, marking the beginning of his journey with the company. As a co-founder, he served as the chief executive officer from its inception. The company's technical approach was radical in its simplicity. All of Ouster's sensors are built on the same core digital lidar technology, a simple two-chip architecture that replaces hundreds to thousands of discrete components commonly found in traditional analog lidar. The first chip is a custom system on a chip containing SPAC detectors. This system on a chip, or SoC, is developed in-house and mass-produced in a standard silicon CMOS process. It counts over 1 trillion photons per second with a natively digital output, 1S and 0S for whether a photon was detected, and also handles the logic and signal processing that runs the sensor. The second key component is an array of VCSELs. Ouster uses VCSELs because they are smaller, lighter, more durable, faster, and more cost-efficient than edge-emitting lasers used in analog lidar devices. The key physical and economic advantage of VC cell technology is the ability to pack many lasers into a dense array. The array on current sensors packs 128 lasers into an area the size of a grain of rice. Importantly, the cost of VCSELs does not increase linearly with each additional laser. This density gives high resolution and low cost in a small form factor today, with plenty of headroom to add more resolution without increasing the size of sensors. Digital lidar is built on the idea that if you can consolidate all of the important functionality of a lidar sensor into semiconductors fabricated in a standard CMOS process, you can put your core technology on a radically different price-cost performance improvement curve than is possible with other analog, MEMS, or silicon photonics-based approaches. At this point, you may be asking, if using SPADs and VCSELs has all of these performance and cost advantages, why doesn't everyone use them? The short answer is that it's really hard to make them work. Ouster has developed tightly integrated, custom vertical cavity surface emitting lasers, cells, and another ASIC that incorporates single photon avalanche diodes, SPADs, arrays. Among these competitors, Pacala stressed, Ouster is the first company to commercialize a high-performance SPAD and VCSEL approach. The third critical component was Ouster's patented micro-optics system, which enhanced the performance of both emitters and detectors to achieve ranges that VCSELs and SPADs alone couldn't reach. Early years and stealth development. The company began quietly, raising seed funding and developing its technology in stealth mode. In December 2017, Ouster emerged from stealth with a $27 million Series A funding round and its first commercial sensor, the OS1. The early years were focused on proving that digital lidar could actually work. Critics argued that VC cells couldn't provide sufficient range for autonomous vehicle applications. They were right, at least initially. Back in 2015, when Ouster first began down the path of digital lidar, the current state-of-the-art detectors and lasers would have produced a sensor with a range of only a few meters. Today, the OS2 has a range of over 200 meters and will continue to improve significantly over time. Crucially, its cost and the cost of all sensors will come down at the same time. This was the Moore's Law thesis in action. Start with a technology that improves rapidly, even if it doesn't initially meet all requirements, because you'll ride that improvement curve while competitors stay stuck on technologies with slower improvement trajectories. For investors, Ouster's founding thesis presents a classic platform investment opportunity. The question wasn't whether Ouster's first sensors were the best on the market. They weren't. The question was whether Ouster's technology architecture would enable faster improvement than competitors over time. This is the same question that defined semiconductor investments for decades. Bet on the trajectory, not just the current position.
The strategic pivot away from automotive only. While most lidar companies had their eyes fixed on the prize of autonomous vehicles, a market that always seemed to be 5 years away, Ouster made a crucial strategic decision: diversify. In 2019, Ouster raised an additional $60 million in a round led by Runway Growth Capital, with contributions from Silicon Valley Bank, Cox Enterprises, Constellation Tech Ventures, Fontanelles Partners, and Carthona Capital. The company opened new offices in Paris, Shanghai, and Hong Kong to scale its international presence. The customer deployments told the story of diversification. Ouster sensors appeared on Postmates' autonomous delivery rovers operating on Los Angeles sidewalks, Kodiak's autonomous trucks in Texas began testing with Ouster lidar for the 2019 DARPA Subterranean Challenge, a spiritual successor to the grand challenges that spawned Velodyne. Ouster sensors were mounted on drones navigating the coal mines of Pennsylvania. This wasn't just opportunistic diversification. Pacala and his team recognized a fundamental truth about the lidar market. Autonomous vehicles might be the biggest prize, but they were also the furthest from commercial reality. Industries like robotics, mapping, mining, and industrial automation needed lidar today, not in some theoretical future. And these customers cared about the same things Ouster's digital architecture delivered: reliability, consistent quality, and improving price performance over time. The second-generation launch. In January 2020, Ouster launched its second generation of lidar sensors, introducing 3 new 128 beam models that demonstrated the improvement trajectory Pacala had promised. The OS0 offered ultra-wide view lidar for navigating urban environments and warehouses. The OS1 provided mid-range capability with 120-meter range and a 45-degree field of view. The OS2 delivered long-range sensing with over 200 meters of range for high-speed vehicle automation. With this product launch, bookings surged dramatically year over year. The company's revenue trajectory began demonstrating the kind of growth that would attract public market investors. In 2019, Ouster was named a CES Innovation Awards honoree for its OS1 to 128 lidar sensor. Praised for delivering high-resolution 3D imaging with 128 channels at a competitive price point. The sensor achieved 2.62 million points per second, a remarkable data density that opened applications requiring detailed environmental mapping. But even as commercial progress accelerated, storm clouds were gathering. The COVID-19 pandemic disrupted supply chains and customer timelines. More significantly, the SPAC wave was building in public markets, creating both an opportunity and a trap that would define the next phase of the lidar industry's evolution.
The lidar SPAC wave. In retrospect, the years 2020 to 2021 look like a fever dream for the lidar industry. Company after company rushed to public markets through special purpose acquisition companies, SPACs, raising capital and achieving valuations that assumed autonomous vehicles were right around the corner. On July 2, 2020, Velodyne lidar merged with Graph Industrial Corp., a special purpose acquisition company, to become a publicly traded company. Velodyne's merger marked the beginning of the wave. Luminar followed, then Innoviz, AI, Ava, and others. In March 2021, Ouster completed its own merger with Colonnade Acquisition, a special purpose acquisition company, and became publicly traded on the New York Stock Exchange. The timing captured both the promise and peril of the SPAC era. For hardware-heavy, pre-profit companies with long development cycles, SPACs made a certain logic. Traditional IPOs required extensive profitability or near-term profit visibility. Venture capital markets, while flush with cash, often struggled to support the capital intensity of hardware development through multiple product generations. SPACs offered an alternative: access to public market capital based on projected revenue rather than actual profitability. But valuations were based on projections that assumed autonomous vehicles would deploy at scale within years. These projections looked increasingly optimistic as the technical challenges of full autonomy became more apparent and economic conditions shifted. The Sense Photonics acquisition. Even amid the SPAC frenzy, Ouster was executing strategic acquisitions to expand its technology portfolio. In October 2021, Ouster agreed to acquire Sense Photonics in an all-stock deal valued around $68 million at the time of announcement. Sense Photonics brought solid-state flash lidar technology designed specifically for automotive applications. On completion, Ouster established Ouster Automotive as a new business arm, headed by Sense CEO Shauna McIntyre. The acquisition added capabilities for automotive ADAS applications and expanded Ouster's product portfolio beyond its core spinning digital lidar sensors. This was classic technology company playbook: use public market currency, stock, to acquire complementary technologies and teams. The strategic rationale was sound. Ouster needed automotive-grade solid-state sensors to compete for the largest prize in the lidar market, but the execution would occur against an increasingly challenging backdrop. Velodyne's unraveling. While Ouster was building, its future acquisition target was unraveling. In January 2020, David Hall stepped down as CEO and was succeeded by Anand Gopalan, the former CTO, although Hall initially remained as chairman of the board and the company's largest shareholder. In January 2021, the company removed Hall as chairman of the board and terminated the employment of his wife, Marta Toma Hall, amid a dispute in which both the Halls and the company accused each other of misconduct. In November 2021, Gopalan was replaced as CEO by Theodore Ted Tewksbury, a former chief executive of Ida Compute, a low-power AI vision systems company. The founder, who had invented real-time 3D lidar for autonomous vehicles, was now locked in a proxy battle with the company he had created. Stock prices declined. Management turnover created strategic uncertainty. The company that once dominated the lidar industry was struggling to maintain momentum. For investors, the Velodyne situation illustrated a perennial risk in founder-led companies. What happens when founders and boards diverge on strategy? Hall had built an extraordinary technology, but building a sustainable public company required different skills. The boardroom drama consumed attention and resources that might have been better directed toward competition and customers.
The industry reckoning. By late 2022, the lidar industry faced a reckoning. The SPAC valuations had collapsed. Customer timelines had stretched. The question was no longer whether consolidation would happen, but who would be left standing. Both Velodyne and Ouster had been struggling with plummeting stock prices. Neither company had achieved profitability. The math was becoming painfully clear. The industry had too many players chasing insufficient near-term revenue. Something had to give. After going public 10 months earlier via a SPAC with China's CITIC Capital, at an implied $1.4 billion equity value, lidar maker Quanergy filed for Chapter 11 bankruptcy. It was one of the SPAC market's fastest fails. The Quanergy bankruptcy, a company where Pacala had once worked, demonstrated how quickly lidar companies could go from SPAC darling to bankruptcy court. The deal that would reshape the industry came together in November 2022. Ouster and Velodyne announced an agreement to merge in an all-stock transaction, splitting ownership of the combined entity evenly between the two companies' shareholders. The deal structure. The merger was structured as a merger of equals, with existing shareholders of both companies receiving roughly equal ownership in the combined entity. Ouster and Velodyne announced the successful completion of their merger of equals, effective February 10, 2023. Ouster's CEO, Angus Pacala, would lead the new company, while Velodyne's CEO, Ted Tewksbury, would chair its board of directors. When the merger was first announced, the companies said they expected annual savings of about $75 million that could be realized within the first 9 months after the transaction closed. Pacala said he expected the total savings to be somewhat higher. But, he noted, that would come at a cost. The merged company would cut jobs. The combined company would keep the name Ouster and continue to trade on the New York Stock Exchange under the ticker OUST. The merger created a lidar powerhouse with a broad customer base across automotive, industrial, robotics, and smart infrastructure, backed by a robust portfolio of hardware and software alongside deep engineering and commercial teams. Following integration, the combined Ouster expected to operate with a leaner headcount, headquartered in San Francisco. Opposition and strategic rationale. The deal faced opposition from some Velodyne shareholders. Former Velodyne chairman Michael D. resigned from the board, citing concerns about the merger structure. But ultimately, shareholders of both companies approved the transaction. Pacala told CNBC the merger is a major step toward profitability for Ouster. Ouster's products have posted positive gross margins for a while, meaning they sell for more than it costs to make them. Pacala noted that after recent changes to Velodyne's contract manufacturing arrangements, that company's gross margins turned positive as well. This is huge for the merger and for the strength of the combined business, Pacala said. Not only are we increasing the revenue base of the two companies by merging, but it's all positive margin. The merger delivered an extensive intellectual property portfolio, backed by over 20 years of combined experience in lidar technology innovation, a strong financial position, and substantial projected operating expense synergies. I keep saying this and people think I'm crazy, but there's a good chance that smart infrastructure becomes our biggest vertical by a long shot in the next 5 years, Pacala told TechCrunch. The reason is because if you look at the established revenue base for traffic systems, for security systems, it's immense. It's way larger than the revenue generated from camera and radar companies in automotive. The strategic logic was compelling. Combine complementary customer bases, eliminate duplicate costs, consolidate intellectual property, and create the financial runway to reach profitability. The merger represented not just survival, but the opportunity to emerge as a consolidated leader. For investors, the Velodyne merger demonstrated both the opportunity and challenge in consolidation plays. The opportunity: acquiring valuable assets, customers, IP, manufacturing relationships, at distressed valuations. The challenge: integration risk, employee retention, and the possibility that legacy issues, like Velodyne's patent settlement with Hesai, could create future complications. That latter issue would soon prove prescient.
Filing the lawsuit. Just 2 months after completing the Velodyne merger, Ouster went on the offensive against its most formidable competitor. Ouster filed a patent infringement complaint with the U.S. International Trade Commission, ITC, against Hesai Group, based in Shanghai, China, and related entities, requesting that the Commission institute an investigation under Section 337 of the Tariff Act of 1930. Ouster also filed a patent infringement complaint against Hesai in the U.S. District Court for the District of Delaware, seeking an injunction and monetary damages. Ouster's complaint asked the ITC to investigate unlawful imports of Hesai lidar sensors that infringe on 5 valid and enforceable patents owned by Ouster relating to lidar technology. Ouster's patents reflect the substantial investments the company has made in the United States relating to both rotating and non-rotating solid-state lidar systems. Ouster's complaint sets forth how, after the market shifted toward Ouster's digital lidar, Hesai stole Ouster's revolutionary patented technologies and incorporated them into Hesai's competing products. This is not the first time that a U.S. company has brought a patent infringement claim against Hesai. In 2019, Velodyne Lidar brought a patent infringement lawsuit against Hesai. Hesai settled for payment of millions of dollars, upfront and ongoing royalties. The lawsuit reflected multiple tensions simultaneously: competitive dynamics in the lidar market, concerns about intellectual property protection in international markets, and the growing geopolitical tension between the U.S. and China in critical technologies. The settlement agreement complication. But Ouster's legal strategy hit an unexpected obstacle, one created by the very merger that had made the company stronger. Hesai announced that the U.S. International Trade Commission, ITC, terminated an investigation of alleged patent infringement that was commenced by Hesai's competitor, Ouster. On October 10, 2023, the ITC commissioners affirmed an August 24, 2023, initial determination by the presiding ITC administrative law judge granting Hesai's motion to terminate the ITC action. Hesai argued that Ouster had sued in contravention of Velodyne's patent cross-licensing agreement with Hesai, which Hesai said bound the combined Ouster-Velodyne entity. Hesai also argued that Ouster was bound by the prior agreement. The presiding administrative law judge, ALJ, recommended, following a motion by Hesai, that the investigation be terminated to allow arbitrators time to decide whether Ouster is required to arbitrate based on a prior settlement agreement between Velodyne and Hesai entered in 2020, before Ouster and Velodyne merged in February 2023. The initial determination is not a decision on the merits of Ouster's ongoing patent infringement case against Hesai. The irony was painful. Velodyne's 2020 settlement with Hesai, signed years before the merger, potentially bound Ouster's hands in enforcing patents against its Chinese competitor. The very assets Ouster had acquired were complicated by agreements made before the merger. The competitive and geopolitical dimensions. The Hesai dispute played out against a backdrop of rapidly shifting competitive dynamics. Yole Group's Lidar for Automotive 2025 report, which ranks lidar companies by several key indicators of success, noted that Hesai captured 33% of the global market by revenue in 2024. Well, yeah, the competitive landscape has shifted dramatically. In the overall automotive lidar market, Hesai leads with 33% market share, followed by RoboSense, Huawei, and Seond. Together, these 4 Chinese companies control 89% of the total market. The lidar market for passenger cars has been surging, driven largely by rapid ADAS adoption in China. In December 2024, Hesai said it became the first lidar company to ship more than 100,000 units in a single month. For Ouster, the competitive picture presented a stark challenge. Chinese companies had achieved scale in the world's largest electric vehicle market with cost advantages from vertical integration and government support. Ouster's path to success would require either winning in markets where Chinese competitors faced restrictions or achieving technological differentiation significant enough to justify premium pricing. The geopolitical dimension added another layer. Hesai faced scrutiny from U.S. regulators and lawmakers concerned about Chinese technology in critical infrastructure. Ouster and its lobbyists had been vocal about potential security risks from Chinese-made lidar. Hesai defended itself vigorously, noting that its sensors don't store data and have been certified for cybersecurity compliance. For investors, the Hesai litigation highlights several important dynamics: the value and complexity of patent portfolios in technology industries, the challenges of integrating acquisitions with existing legal commitments, and the way geopolitical tensions create both risks and opportunities in technology markets. The ultimate resolution of the Ouster-Hesai dispute remains pending, creating continued uncertainty about
financial progress. By the end of 2024, Ouster had demonstrated meaningful progress toward its strategic goals. Fourth quarter revenue increased substantially year over year and sequentially, with thousands of sensors shipped. GAAP gross margin improved markedly compared to the prior year and previous quarter. The fourth quarter capped off a year of consistent execution, record financial results, and delivering increased value for our customers. In 2024, we grew OS sensor volumes by over 50%, increased our software-attached bookings by over 60%, and deployed sensors at iconic events like the Paris Olympics. We also reached major milestones in the development of our next-generation custom silicon chips and new tools to accelerate lidar adoption. The company's liquidity position remains strong, with substantial cash reserves and no debt at the end of fiscal year 2024. Our strong first quarter results demonstrate continued operational execution. We generated revenue of $33 million and gross margin of 41%, winning multi-million-dollar deals across all four of our verticals. The improvement in gross margins represented perhaps the most significant operational achievement. Hardware companies live and die by gross margins, and Ouster has demonstrated that its digital lidar architecture can deliver the kind of margins needed to build a sustainable business. Strategic partnerships and defense applications. Recent strategic wins illustrate Ouster's diversified approach to market development. Ouster was selected as the lidar supplier for Komatsu's suite of autonomous mining equipment offerings. The two companies signed a multi-million-dollar agreement to equip Komatsu's equipment with advanced 3D digital lidar sensors. Ouster's products developed through this partnership can withstand the shock, vibration, and temperature constraints while delivering the enhanced range and spatial awareness necessary to operate in harsh mining environments, said Matt Relan, Technical Director, Automation Innovation at Komatsu. This agreement marks a significant milestone in Komatsu's ongoing journey to advance mining automation and safety. The Komatsu partnership demonstrates Ouster's strategy of targeting industrial applications where lidar provides immediate value, rather than betting everything on the longer-term autonomous vehicle opportunity. Perhaps more significantly for investors, Ouster secured an important defense validation in 2025. Ouster announced that its OS1 digital lidar has been vetted and approved by the Department of Defense (DoD) for use in unmanned aerial systems (UAS). Following a review of components and cybersecurity testing, the Defense Innovation Unit approved and added the Ouster OS1 to the Blue UAS framework. Blue UAS is a holistic and continuous approach that rapidly vets and scales commercial UAS technology for the DoD. The Blue UAS framework is an approved list of Interoperable National Defense Authorization Act (NDAA) compliant UAS components and software that provide options for government and industry partners. The Ouster OS1 is the first high-resolution 3D lidar sensor approved under the Blue UAS framework and offers superior performance in weight, power efficiency, and reliability under rugged conditions compared to previously approved 2D lidar solutions. Ouster is committed to the responsible development of its products and has taken significant steps to secure its supply chain, said Ouster CTO Mark Frichtel. As a result, our OS-1 sensor was officially added to the Blue UAS list, providing drones and other UAS with access to industrial-grade, high-fidelity spatial awareness for advanced perception and autonomous operation. Ouster is proud to be the leading supplier of 3D lidar sensors for U.S. defense applications. The Blue UAS approval represents a significant strategic milestone. Defense applications typically offer higher margins, longer customer relationships, and potential for multi-year contracts. Moreover, as geopolitical tensions elevate concerns about supply chain security, Ouster's NDAA compliance positions it favorably against Chinese competitors in government and defense-adjacent markets. Technology Roadmap. Ouster continues to advance its technology roadmap, with several initiatives aimed at expanding addressable markets and improving economics. During the second quarter of 2024, Ouster taped out its automotive-grade custom silicon Chronos chip. The company expects to integrate Chronos into its solid-state digital flash DF sensors in the next year. Development on the company's next-generation custom silicon L4 chip is advancing with validation testing underway. Both Chronos and L4 are expected to open up new verticals and bring significant improvements in performance, reliability, and manufacturability to the Ouster product family. The Chronos chip harnesses Ouster's proprietary digital lidar architecture and some of the latest advancements in semiconductor technology. This design allows Ouster's DF sensors to benefit from the same dramatic performance improvements that made the digital camera ubiquitous across industries. With superior logic and performance capabilities, the Chronos chip delivers improved memory, dynamic range, and detection accuracy. Ouster expects the Chronos chip to be the most powerful SPAD-based lidar chip produced to date. The product portfolio transformation we have planned in 2025 will result in the largest increase in Ouster's addressable market in our history.
The bull case. Technology moat through digital architecture. Ouster's fundamental bet on digital lidar built around VC cells and SPADs appears to be playing out. The company's gross margin expansion demonstrates that its architecture enables improving economics over time, consistent with the Moore's Law thesis Pacala articulated at founding. As Apple, consumer electronics companies, and others continue investing in VC cell and SPAD technology, Ouster rides those improvements without bearing the full R&D cost. Diversified revenue base. Unlike lidar competitors who bet heavily on autonomous vehicles, Ouster has built meaningful revenue across industrial, robotics, and smart infrastructure applications. This diversification provides revenue stability while the autonomous vehicle market matures. Defense and security. Opportunity. The Blue UAS approval opens a growing defense market where NDAA compliance creates barriers to Chinese competitors. With the Pentagon pursuing aggressive drone expansion programs, Ouster is positioned to supply perception technology for military applications. Intellectual property portfolio. Backed by over 20 years of combined experience in lidar technology innovation, Ouster possesses one of the industry's strongest patent portfolios. This IP provides both defensive protection and potential licensing revenue. Path to profitability. The combination of revenue growth, gross margin expansion, and operating expense discipline has Ouster tracking toward profitability. Ouster said it remained committed to its long-term framework, sustaining strong revenue growth, expanding gross margins, and keeping operating expenses disciplined. The bear case. Chinese competition. In the overall automotive lidar market, Hesai leads with 33% market share, followed by RoboSense, Huawei, and Seond. Together, these four Chinese companies control 89% of the total market. Chinese competitors have achieved scale, cost advantages, and dominant positions in the world's largest EV market. If Chinese companies expand successfully into Western markets, Ouster faces intense price competition. Autonomous vehicle timeline risk. The largest prize in lidar remains autonomous vehicles at scale, but deployment timelines continue to extend. If full autonomy takes another decade, Ouster must sustain itself on industrial and robotics applications that represent smaller total addressable markets. Technology substitution risk. Some autonomous vehicle developers, most notably Tesla, argue that camera-only approaches can achieve full autonomy without lidar. If this proves correct, the long-term addressable market for lidar shrinks significantly. Additionally, advances in 4D radar technology may capture some applications currently targeted by lidar. Patent litigation. Uncertainty. The Hesai litigation remains unresolved, with the outcome potentially affecting Ouster's ability to enforce patents against its largest competitor. The Velodyne settlement agreement complication illustrates how M&A can create unexpected legal constraints. Capital intensity. Hardware companies require ongoing investment in R&D, manufacturing, and inventory. While Ouster's balance sheet remains healthy, continued losses require either reaching profitability or additional capital raises that could dilute shareholders. Framework analysis. Porter's 5 forces. Supplier power, moderate. Facel and SPAC components come from a limited number of suppliers, but are increasingly commoditized. Buyer power, high in automotive. OEMs have leverage, moderate in industrial, more fragmented. Competitive rivalry, intense. Multiple well-funded competitors, including Chinese companies with government support. Threat of substitutes, moderate. Cameras and radar represent partial substitutes, though lidar offers unique capabilities. Barriers to entry, high. Significant R&D investment, manufacturing expertise, and customer relationships required. Hamilton-Helmer's 7 powers. Scale economies, building, as sensor volumes increase and manufacturing efficiency improves. Network effects, limited direct network effects, though software ecosystem could create some switching costs. Counter-positioning. Ouster's digital architecture represents counter-positioning against analog lidar approaches. Velodyne's original approach couldn't easily pivot to digital without abandoning existing technology investments. Switching costs, moderate. Customers invest in integration, software, and training specific to Ouster's products. Branding, growing, particularly in industrial and defense applications. Cornered resource. Patent portfolio represents a potentially cornered resource, though effectiveness depends on enforcement. Process power, potentially developing through manufacturing expertise and supply chain relationships.
For investors tracking Ouster's ongoing performance, 3 KPIs warrant primary attention. 1. Gross margin. Trajectory. This is the single most important indicator of whether Ouster's digital lidar thesis is working. Consistent gross margin improvement validates the Moore's Law economics that underpin the company's strategy. This expansion represented exceptional progress. Investors should monitor whether margins stabilize at current levels, continue expanding, or face pressure from competitive pricing. 2. Revenue growth rate. Ouster has laid out an ambitious long-term growth framework. Consistently meeting its own targets would signal market acceptance and customer retention. Falling short could point to competitive pressure or a smaller-than-expected market. 3. Book-to-bill ratio. Investors watch whether bookings outpace revenue. When they do, it typically signals rising demand and a growing backlog that supports future revenue. When they don't, it can be an early warning sign of softening demand.
Several regulatory and legal matters warrant investor attention. Hesai litigation. The patent dispute with Hesai remains pending, with potential outcomes ranging from settlement to continued litigation. The Velodyne settlement agreement complication creates uncertainty about Ouster's ability to enforce certain patents against Hesai. NDAA compliance. Ouster has positioned itself as NDAA compliant, which enables access to U.S. government and defense markets. Maintaining this compliance requires ongoing attention to supply chain security. Export controls. As geopolitical tensions continue, U.S. export control regimes may affect the lidar industry. Changes to regulations could either benefit Ouster by restricting Chinese competitors or create compliance challenges. Autonomous vehicle regulations. The pace of autonomous vehicle deployment depends significantly on regulatory frameworks that continue evolving across jurisdictions.
The Ouster story is not yet written. The company has survived the SPAC bubble, consolidated with its industry's original pioneer, and demonstrated a path toward profitability. But significant challenges remain. The competitive landscape has shifted decisively toward China, with Hesai and other Chinese manufacturers achieving scale that American and European competitors struggle to match. The automotive lidar opportunity, always the biggest prize, remains distant as full autonomy proves more difficult than early projections suggested. Yet Ouster has built meaningful advantages: proprietary digital lidar technology with demonstrable economic improvements, diversified revenue across multiple verticals, defense market access that Chinese competitors cannot easily replicate, and a patent portfolio that provides both defensive protection and potential offensive capability. The question for investors is whether these advantages compound over time faster than competitive pressures erode them. Ouster's digital architecture provides a structural advantage in cost and performance improvement, but only if that improvement outpaces what competitors achieve through scale and vertical integration. By consolidating all the complexity of analog lidar onto a single silicon CMOS SoC, Ouster dramatically improves performance while reducing costs over time. Ubiquitous technologies such as computer processors and digital cameras have all followed this same exponential improvement curve, known as Moore's Law. The company's lidar technology progresses along the Moore's Law curve, delivering improvements to performance and cost that will help to make lidar ubiquitous. That, ultimately, is the bet. That digital lidar follows the same trajectory as digital cameras, with Ouster riding that curve to market leadership. It is the same bet that defined semiconductor investments for decades. The bet on exponential improvement curves outpacing linear optimization. For Angus Pacala and his team, the journey from quitting Quanergy in frustration to acquiring Velodyne represents vindication of their technological thesis. But in technology markets, vindication is only the beginning. The harder work of building a sustainably profitable business remains ahead. The machines are learning to see. The question is, who will give them their eyes?
This podcast is brought to you by Empor.top, the stories of top companies. Disclaimer: this AI-generated content is for informational purposes only and should not be considered as investment advice.